Hi, and welcome back to Atomic Math. Today we're going to look at something called trigonometry. And specifically, we're going to look at the part of trigonometry that we use to solve for vectors. So let's start with a right angle triangle. We can see that it is a right angle in the corner there, and we have some theta on the other side. The long side we know is the hypotenuse. Along the bottom is the adjacent, and the vertical side is the opposite. Now we have some identities that we can use with this. We know that the sine can be found by doing the opposite over the hypotenuse. Cos can be found by using the adjacent over the hypotenuse. And tan equals either sine over cos or the opposite over the adjacent. Now let's go ahead and add a vector so we can look at how we use this. You can see that we can solve for the x component and the y component by using this right angle triangle, and of course our identities that we've already identified. So if we wanted to find the x component, for example, we could use the cos theta equals adjacent over hypotenuse, and we could write this instead now as cos theta equals the x component over the size of the vector. And if we rearrange that, we could solve for the x component and say that cos theta times the length of the vector would give us our x component. So how would we find our y component? Well, let's use sine. Sine is opposite over hypotenuse, so we can write that as sine theta equals the y component over the length of the vector, and then we can express that in terms of the y component, so we have sine theta times the length of the vector. So now we have ways of finding our x component and our y component. So now let's just look at an actual question. A ladder leans against a wall at a 60-degree angle. The ladder is 10 meters in length, and we have to find the height of the ladder on the wall. So let's start by adding our wall. Then we'll throw our ladder in there. That 60-degree angle that it is represented. Of course, this one's a 90-degree angle, and they've told us that our ladder is 10 meters in length. What we need to find is this. We need to find how high up the wall is the ladder. So how do we find that? Well, we need to find the y component, and we use the equation right here that we've already created to solve for y. So y, which in this case will be the height, is just going to be the sine of 60 degrees times 10 meters. So our height is 8.66 meters. Pretty easy. It's a lot easier when you draw a picture so you can see what you're looking for, and then it was a simple equation. But of course, you need to be able to see that, and the picture is what will help you do that. Now let's look at something called displacement. Displacement is not the same thing as distance traveled, because displacement is a vector, and the distance traveled is a scalar. So let's look at an example so we can see the difference. You travel north for 2 kilometers, then you turn and travel east for another 4 kilometers. Then you turn again and go another kilometer north. So as far as your car is concerned, you have traveled a distance of 2 plus 4 plus 1. You've traveled 7 kilometers. But displacement is different. It doesn't care about what route you took. It only cares about where you started and where you finished. So for displacement, we need to look at this vector here, because like I said, it only cares about where you started and where you finished. Now, in the previous examples, we looked at how we could use this right angle triangle to tell us the components of a vector. Now, this might not look like we have the same situation, but we do. We just have to manipulate our lines just a little bit. So let's bring this guy right over here, because that doesn't change the fact that you're still going 2 kilometers north. And if we drop this one right down here, again, doesn't change the fact that you're going 4 kilometers east. So now we have what looks like a right angle triangle, and we can use it to solve our vector. So we can express the vector like this. So 4 in the x direction plus 2 in the y direction plus another 1 in the y direction, which would give us 4 in the x, 3 in the y. So we can just write the vector like this. Now let's say that I wanted to know the distance between my beginning and my end, not by my root, but just the length of the vector itself. So we would use something called Pythagorean's theorem. So if we wanted to solve for this length, which we represent as this symbol here, we would say that that squared equals 4 squared plus 3 squared. So if we wanted to solve for that, we would just take the square root of both sides, and then we would get down to square root of 25, and we would find that the length of that vector is 5 kilometers. So let's do a quick recap on what we learned. We know that the sine is the opposite over the hypotenuse. Cos is adjacent over hypotenuse. The tangent is either sine over cos or opposite over adjacent. We also learned that with the triangle, a squared plus b squared equals c squared. And of course, the most important part is that we can express a vector in terms of its components, the x component and the y component. So, if you found this video helpful, go ahead and hit like, and if you want to see more videos like this, hit subscribe. And in an upcoming video, we are going to use this to solve some kinematics equations. See you in the next video.